So in this last intro lesson that I want to go over, dealing with acids and bases, we're going to touch on something called pH and pOH, or just basically, it's just an easier way of being able to represent the H plus concentration or the OH minus concentration within a particular reaction, because of the fact that these concentrations are usually very small. You're usually talking about the negative, something to the negative 11 or something to negative 14 even. So very small concentrations, so a lot of the times it's not that easy to be able to figure out if something is acidic or basic or neutral. So that's where the pH scale comes into play. So first I want to go over just some of the overall equations that you'll use in this case to be able to find pH and pOH. Just know that it's always going to be something to the negative log, and then just know that they go together, meaning if you're looking for pH, you need to have your H3O plus. If you're looking for OH, you need to have your OH minus. And just know that that's what you're going to come out with, when you do these particular calculations. And then if let's say you're given OH, but you want to find pH, then you could use this equation, which is just 14 equals pH plus pOH. 14 being the highest you can possibly get, when on the pH scale. So here's an example where you're given hydronium concentration. So hydronium again is just basically H3O plus, and you want to find the pH. So this type of problem is really easy to do because it's just going to be pH equals the negative log of the hydronium concentration, so just 2.9 times 10 to the negative 4. So just plug that into your calculator, and you should end up with 3.54 as the answer. So again, really easy to do. And with these type of problems, the main thing is to make sure you read it through carefully to see exactly what it is that you're given and what you're looking for. For example, in this example, the second example, you're looking for a pH, but you're given OH. So you do have to make sure that you pay attention to that. Another thing you need to make sure you pay attention to is just, like I was mentioning before, that subscript, because you are going to need to take that into account. So in this case, let's say we just go out and find, what we could find is just pOH because of the fact that we are given OH, the OH concentration. So it's the negative log 2.5 times 10 to the negative fifth, but again you need to take that 2 into account, so you'd multiply that by 2. So you end up with a pOH of 4.30. And one thing I didn't mention, that is important to know is pH and pOH, they're always going to be represented by 2 decimal places. So you make sure that you always report your pH and pOHs to 2 decimal places. That's the norm for all this. But anyways, so in this case we found out that you have pOH at 4.3. Well, in this case though, you're looking for pH. So one way you can do this is just basically pH equals 14 minus 4.30, and that'll give you your pH, which is 9.70 in this case. Alright, so that was going from concentration to pH or pOH. In this case, we want to go the opposite way, where you might be given the pH or pOH of a particular reaction, or a particular solution, and you want to figure out the concentration. When doing that, you'll use these equations where it's just going to be, if you're looking for hydronium, let's say, it's going to be equal to 10 to the negative pH power. And if you're looking for OH, it's going to be 10 to the negative pOH power. So again, it goes along with if you're given, if you're looking for if you're given pH, you're going to be left over with H3O plus. If you're given OH, you're going to be left with OH. So it goes along together. So here's an example. In this case, you have a pH of 7.40. and you're looking for hydronium. So it's a relatively easy calculation. You're looking for hydronium, which is equal to 10 to the negative pH power, which in this case would be a negative 7.40. put that into your calculator, and you should end up with 3.9 times 10 to the negative 8 molar, and that would be the concentration in this case. Now for this example, there are two different ways you could possibly do it. You're given a pH, but you want to find hydroxide. So one way of doing this is just taking 14 and minus 10.60, which would give you 3.40, and that's just basically the pOH. So if you're given the pOH now, you can easily go and plug it into this equation, which is OH minus equals 10 to the negative pOH, which is negative 3.4. So that'll give you your concentration of 3.98 times 10 to the negative 4 molar. Another way of doing it is just maybe putting it into the hydronium equation, where it would just be 10 to the negative pH. You end up with the hydronium concentration, and then you could use your Kw expression that we used in the previous tutorial, where it's just 1 times 10 to the negative 14th, and you would divide that by the concentration you got. A little bit more difficult because you're dealing with scientific notation. With pH, it's a little bit easier to be able to figure that out. So that ends the intro to acids and bases. One thing that I do recommend is that you get a good handle on being able to calculate concentrations and pH and pOH, and being able to go from one to the other rather quickly, because once we get into equilibrium, it's going to be all this is a foundation to that. So if you don't know how to do this, you'll have a rather difficult time with equilibrium, because now you're trying to figure out two things instead of just figuring out the equilibrium part.